What if a single injection could permanently rewrite your DNA to slash your heart disease risk forever? That is not science fiction anymore. This week, the first human just received a gene therapy designed to do exactly that. And today, we are going deep on this story because it may be one of the most significant developments in cardiovascular medicine in decades. Welcome back to BioHackers Longevity. Today we have one major development that deserves our full attention. A single-dose gene therapy that may permanently lower cholesterol and transform how we treat heart disease. Let us get into it. VERVE-102 is a base editing therapy, a more precise cousin of CRISPR, that makes a permanent change to the PCSK9 gene with a single dose. PCSK9 is a key regulator of LDL cholesterol, and people with naturally low PCSK9 activity have dramatically lower rates of heart disease. Early clinical data on VERVE-102 shows substantial reductions in LDL cholesterol that appear to be durable. If this holds up, we are talking about a one-time intervention that could replace decades of daily statin use for high-risk patients. Heart disease remains the leading cause of death globally, so the stakes here are enormous. Let us break down what makes this technology different from anything that came before it. Traditional CRISPR cuts DNA. It is essentially molecular scissors. Base editing, by contrast, does not cut. It chemically converts one DNA letter into another with far greater precision and far less risk of unintended off-target damage. That distinction matters enormously when you're talking about a permanent, irreversible change to the human genome. The PCSK9 target itself is well validated. We have decades of data from people who were born with naturally low PCSK9 function. They carry dramatically reduced cardiovascular risk throughout their lives with no apparent downside. Existing PCSK9 inhibitor drugs, like injectable antibodies, have already proven the concept in clinical medicine. What VERVE-102 is attempting is to achieve that same biological outcome permanently through a single intervention, rather than requiring ongoing treatment. Now, let us be precise about where the science actually stands. Early clinical data is promising. We are seeing meaningful LDL reductions. But long-term safety data for permanent genetic modifications in humans will take years to accumulate. A one-time change to your genome is, by definition, irreversible. That demands an extremely high bar of evidence before this moves into broader use, and the scientific community is right to hold it there. The therapy is currently not available outside of clinical trials, and it is designed for high-risk patients. People with conditions like familial hypercholesterolemia, where standard treatments are insufficient. This is not a near-term consumer longevity tool. It is a serious medical intervention moving through a serious regulatory process. Step back and look at what VERVE-102 represents, and a clear theme emerges. The most powerful interventions target biological constraints at the root, rather than managing cholesterol day by day with a daily pill. Base editing asks whether we can solve the underlying genetic regulation once and permanently. That shift in thinking, from management to correction, is where cardiovascular medicine is heading. The field is maturing fast, and this is one of the clearest examples of that maturation in real time. If you found value in today's deep dive, hit subscribe so you never miss an episode. Drop a comment below telling me what question you most want answered about gene therapy and cardiovascular risk. I read everyone. Next week, we are diving into new research on sleep architecture and its connection to metabolic aging. See you then. This information is for educational purposes only. Always consult your doctor before making any changes to your diet, supplements, or medication.